Hi guys, this is Ableton Bible, and in this session we're going to be taking a look at bass processing and mixing. So in this project what I've done is I've gone through all of the bass sounds that we've been synthesizing in the previous videos, and I've combined them all and put them all into this one project. So I'll just go through these now so you can hear them all again. So the reason I've combined all the sounds like this is because I've got quite a few different techniques and processes that I want to go through to do with mixing, and it's a lot easier if I can pick and choose between these different basses to make sure that I get the fundamental concept of the techniques across without having to force it upon a bass sound that might not necessarily benefit from that technique. So that's the reason why I've done it like this. So what we'll do now is we'll go to our first bass and we'll look at what sort of techniques we can teach on bass 1. So the first thing I'm going to show you is bass panning and stereo imaging. We can start off by saying that the bass should always be centrally panned. So we're not going to hard pan it left or right. It needs to be in the center of the mix and preferably in mono, because that's where all of the punch and the main energy of a track is going to be put forward. So if you start panning it to the side, it's going to lose a lot of that power and momentum. So I can just show you that now by panning this to the right hand side. You can hear it really lacking that power and punch. It's got no weight whatsoever. It sounds like it's more of a pad when we pan it like this. And you might notice that this sound isn't mono either. If we look at the fader of this track, we can see that we've got a difference between the left and the right channel. And that's probably because of some sort of stereo effect. So if we actually go into the plugin, go into Massive, we see we've got a dimension expander on there. And we've also got a delay which will be causing this. So that's the first main point for the bass, is to keep it centrally panned and keep it in mono, or at least keep the lower part of it in mono. The reason we don't want any stereo effects or severe panning below 100 Hz is because it's going to lose a lot of the power and the punch to the track, and also we're going to get a lot of smearing and loss of clarity because of phasing issues, which is a really big problem below about 200 or 300 Hz. So this brings us nicely onto our next topic, which is frequency splitting. So we've got ourselves a bit of a typical scenario where we have our bass and we might want to affect the different EQ bands of the bass differently. So we might want to use a chorus on the mid band, we might want to use a delay on the higher band, and we want to keep our sub band nice and mono, so we've got that power and punch, we don't have any phase issues. So we need to find a way that we can split up our bass. It makes it easier for processing and stops us getting so many issues when we get to the mixing phase. So there's a few different ways we can do this, and the first one is by using an EQ device. So we're just going to go ahead and get the EQ8 device, and what we're going to do is we're going to turn off the first band, and then we're going to take this last band, we're going to put it all the way down. So it's a low pass filter, and we'll set it at about 60 Hz, and we'll change it to a slightly more gentle slope. And then what we can do is we can group this with itself. So obviously we've got our sub here now, and then if we go into the chains, we can duplicate this chain, and we're just going to rename these. So we've got sub, and this one can be top bass, and then we can just change this main bass from a low pass filter to a high pass filter. So now we've got our top and we've got our sub. So if we listen, what we can now do is just tweak these slightly and get the crossover frequency exactly where we want it. So we're getting the best from our sub and our top. So the crossover frequency here is really important. Okay, so now that we've got these frequencies split, what we can do is affect them differently. So the sub, we want that to be nice and mono. So if we just have a listen, we can actually see that's not quite mono. So what we can do is drop a utility on there and just pull the width down to 0, so it's only a mono signal coming through now. And we can see that in the track fader as well. It's nice and flat in both the left and the right channel. And likewise with this top bass, we can now think about putting some effects on here. So we'll go with the chorus device. I'll just drop that on, and I'll just changed it so it's modulating on both delays, and we'll just pull the high pass down, and we're getting modulation on both the delay lines of the chorus. We're getting a lot of stereo imaging, but it's not going to affect our sub. And if we turn this audio effects rack on and off, the problem we're going to notice is that this chorus is causing us a lot of transient information loss. Yeah, you can hear it's a lot smoother and rounder, which may be what you want, or it may not be. And that's because of things like constructive and deconstructive interference or phasing. So what we can do is we can push this up to 100%. And if we duplicate this again, so Command and D, so this can be called top chorus. And we can call this one top dry. And then all we have to do is just get rid of the chorus on this one. This one is set to 100%. And we can even do this again if we want. We can duplicate. And we might want another effect in there. We might get rid of the chorus. We might have a bit of a saturator maybe. And a simple delay. So we'll go for 100%. And switch these to time mode, so in milliseconds, and then we'll choose 30 and 40 milliseconds in the left and right channels respectively. And I'm also going to add some saturation, so I'll just give it 2 decibels of drive, and then I'll remove 2 decibels off the output to compensate for the change in level. Just going to make some slight adjustments to some of these delay timings. I'll just move these down a little bit. Go for 15 and 25 milliseconds. And if we want to go one step further, what we can do is we can use the macro controls. So just map this to macro 1, map to macro 2, and we just need to rename this. So this is our delay, and then the sub. So once we've mapped all these, we can just go in and rename them in the device rack. And this now allows us to mix these and set the relative levels for each effect within the device rack. We can call that our bass rack. So we're almost mixing it from this bass rack. And this can be useful, but some people don't like doing that because it can get a bit messy when you're trying to mix loads of tracks up here and you're not sure what's going on in each individual track. So the other way of doing it is we just command and duplicate this. So we've got bass 1, and then we've got bass 1 sub. And what we can do here is we can either keep this on and just filter it right down, or what I'd probably prefer to do is just drop an operator device on, get rid of the bass rack, and just pull this down. So let's have a listen. And just get rid of any clicks and pops and anything that might not be doing the signal any justice. And we could also distort it a bit if we wanted to. Maybe we want a little bit more harmonic content in there. And there we go. Now all we have to do is put another filter back on here. So we go EQ8. And then we can do exactly what we were doing a second ago, but instead we're mixing up here instead of down here. And we can also affect this and make it mono. We can affect this and make it less mono, or however we want to work it. And talking about mono and stereo, I just want to show you another little trick, which is the mid-side technique. So I'm just going to get rid of this sub. Go back to our bass 1. And we'll get rid of spectrum. We'll get rid of this. And if we drop on a utility device, we can use this to change between mono and stereo. So if we look at the moment, here and here, we'll see we've got a bit of stereo information. I'll make some more stereo. Now we can turn that to mono. So now you can't hear anything apart from the mono information. What it's doing is it's disregarding the stereo information. And likewise, if I push this up to 200%, it's going to disregard the mono information. We're only going to get the stereo. So a good little trick is if we group this to a chain, duplicate the chain, and we're going to have mid and side. And what we've now got here is a nice simple little mid-side rack. And what we've got to do is make sure the side's at 200% and the mid is at 100%. And if you listen now, it's not made any difference to the signal because they're both at their set level. But a standard thing to do would be to push up the side volume slightly. And now we can also put a EQA onto the side channel, and we can high pass filter the side channel so that there's no bass information in the sides of the mix. So that is our little mid-side rack. And you can actually also do something similar using just an EQ. So if you drop an EQ8 on, you can actually change it here from stereo or left-right mode. You can change it to mid-side mode. And in mid-side mode, so we've got our mids here. So we could maybe reduce a bit of the top end and save that for more important things in the mix. So we've got like vocals and drums and hi-hats and things. We want to keep it nice and airy. And then we can go to our sides, and we can just cut out all of the sub information from our sides. So our sides, and maybe give it a boost up the top. So our side information is going to have a lot more sort of clarity, where you get things like reverbs and effects and stuff. So just listen. So that's mid-side using EQ. And the final thing I want to show you is just going back to frequency splitting. There are other ways of doing it. So if you do want to go the plugin route, you can get plugins such as BX Digital or BX Control. And if we just drop this on, this is a nice simple tool. So I'll just turn this up so we've got a bit more side information again. So if things are getting a bit messy, you can just throw this on and you can just look and you can see that obviously we've got a bit of a peak here and it's going from left to right. So it's not perfectly centrally panned. There's a bit too much going on. So we could just bring that way slightly, try and even that out. Our correlation meter is looking okay. If it gets to 0, it's getting a bit dodgy. So what we can do is we can make everything mono up to a certain point. So 150 hertz. So if I go all the way to the top, you see we've got mono. Pull this back down. So we'll go to about 150. And then what we can do is the stuff that isn't mono, we can then make stereo. And that's just increasing the stereo width by pushing up the sides, exactly as we did on our own one. So that is the Control plugin by Brainworks. So that pretty much rounds off everything I wanted to say about stereo imaging and panning for the bass. So in the next part of this video, we're going to take a brief look at phase. Okay, so now we're going to be talking about the phase. So what I'm going to do is just choose a different track, and all we're going to be using from it is the beat. So we'll go with this techno beat. And what we're going to do is we're going to make a sampled bass with a new MIDI track, just because I want to show you this in the most clear and concise way I can. So doing that with a sample such as a tom drum is going to make it perfectly clear when I'm talking about how the phase relationship changes and how that's going to affect the sound when it works with a kick drum. So let's just go to the browser and the samples. I'm just going to look for a tom sample with a bit of an interesting character. This one will do. Low tom 4-1. And we're just going to drop that in, and then we're going to drag that bass across, and we might have to change the pitch. We might have to change the octave slightly. Yeah, that's well too low. So I'm just going to get a MIDI effect of the pitch device, and I'm just going to drag this up an octave. So that's a bit more usable now as a bass sample. And then what we're going to do is just shift this along. There we go. That's a pretty standard little bass MIDI patch. So now I'm going to show you how this bass interacts with the kick, but before we do that, just a good bit of housekeeping. Let's rename this to Tom Bass. And then we'll just zoom in on this sample in the simpler. What we can do here is we can actually change the start point by moving this. And you tend to find, so what we've got is we've got a pitch part here. And then we've also got, we can see the waveform, and as we get to 0 crossing points, it's going to change the sound. And if we hit without a 0 crossing point, you'll tend to find we're going to get a click. So I'll just show you that. And even if we filter that, we're still going to get changes in the timbre. So you'll find that if you tweak this setting and you've got a sample that fits harmonically with your kick, then when you tweak this to the exact right part of the cycle of the waveform, it's going to really lock in with that kick and sound really pleasing together. And that's how you're going to get the best sort of tone, especially for these harder genres. So if you're not quite there with the pitch of your sample, then what you can do is either you can re-pitch it by changing the different note in the piano roll, or you can change the transposition within the sampler device, or failing that, you can use the frequency shifter and you can change the sample in hertz. And this does work slightly different to re-pitching. However, this is also a viable option if you want to get a bit of a different tonality or sound. Okay, so moving on from phase, now we're going to be looking at bass equalization or bass EQ. And for this part of the video, we're going to be working with the generic Moog bass that we made earlier. So with bass EQ in particular, what we're mainly trying to do is gain clarity by making sure that we don't have elements getting in the way of each other. So in particular, we've got the drums and we've got the bass, and we might have the fundamentals of some other instruments as well, like pianos and that. So these are all things that we're trying to move out of the way of each other to gain clarity with the bass. And this is usually in the form of either taking notches out of the other instruments or notches out of the bass. So we're going to start off by taking a look at the high pass filter and low pass filter and the shelving EQs in EQ8. So I'm just going to load that up now. And we'll start off by talking about the low pass filter. So what we're actually doing is removing any of the high airy information, or it might be a bit of bit crushing or distortion on the bass. What we're trying to do is get rid of that, which is going to allow our top end of our mix to breathe and come through. So that's how we get things like our airy cymbals as well. And in this case, there's not really much need to low pass filter this because we've made the whole patch in silent and we haven't added any white noise or anything. It's not been sampled off vinyl, so there's not really much going on. We've not really got a great deal of distortion that's going to be putting any information into that sort of 1 kilohertz up to 10, 20 kilohertz range. And if we listen in context, this is a really good way of seeing if there's any masking, is to listen to the drums and see if the bass is taken away from them at all. And then what we can do is just low pass this down. And it sounds like it's not going to make a difference, but what that's going to do is it's going to clear up everything above 1 kilohertz, and it's going to make it a lot more clear for the top end of the drums. And what we can do is we can then readjust this frequency control whilst listening in context, and you'll be surprised at just how far down you can actually get it without noticing that you're taking much more out of the bass. Whereas if you did this in solo, then you'd be a lot more wary that you're cutting a lot of your bass. But at the end of the day, people aren't going to listen to your track in solo, so do it in context, and if it sounds good in context, then cut as much as you need to. So that's my next point, is to make sure that you do things in context as well as solo, especially when you're setting filter cutoffs and things like that. And another thing to be aware of, apart from that, is to make sure you check what sort of filter slopes you're using and where you're setting your cutoff frequencies and crossover frequencies. So I'd recommend using these more gentle filter slopes for these sort of jobs, but you can also use a 24 decibel per octave filter slope, and that's going to be a lot more abrupt in cutting the signal off, and it's going to be a lot more in your face and obvious. And if you want to go for something even more subtle than a 12 decibel slope, then you can try a shelving EQ instead. And also remember that if you're trying to accentuate the point around the cutoff, then you can do that using the Q or resonance control as well. So next I'm going to talk about high pass filters. So we're going to drop on an instance of Voxengo Span. And we're going to set this to low frequency inspection mode. So when it comes to setting the high pass filter, there's no hard and fast rules, but you'll hear people saying different things like 37 Hz, 35, 30, some people even do it at 20. But what I say is that you can be a bit more smart than that, and if you actually look at your MIDI file and look for the lowest note of your lowest instrument, or you use Voxengo Span, then you can use that to guide you and be a lot more accurate about where you cut your bass. So let's just have a look at Voxengo, and we can see we've got a D, and then that goes to a G, and then it goes to an A. So if we go to our MIDI file and have a look, we can see we've got a D, 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 going to a G, 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 and then A, 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 A. And we can see our lowest note is a D1. And just to confirm on Voxengo, we've got a D1 at 36 Hz. So we now know that we can cut everything below 36 Hz on this bass. And this will change the tone slightly, and we've got to be careful because sometimes you get sidebands that are below the fundamental. So this means if we're cutting these away, we are going to change the timbre of the sound. And it's also going to depend on things like the filter slope that we're using and also the frequency. So you just need to fiddle around and see what works. But generally, I like to do this with a pretty sharp filter slope. But if you're using something like FabFilter, you're not going to be wanting to jump in there with a crazy 96 decibel filter. More often than not, a 24 or a 12 is more than enough to do the job. So like I said, where you cut on each track is going to change slightly, and you don't have to go rigidly with 36 Hz just because 36 Hz is the lowest note. If you want to go slightly below and play it safe, then that's probably what I'd do as well, and then use a gentle filter slope. I think in the case of this bass, what I might actually do is change that to a lighter filter slope and actually move it up slightly, just so it's gently rolling off everything below about 40-50 Hz. So now that we've spoke about high and low pass filters, we need to talk about the tonal balance and shaping of our bass sound. So I'm just going to play this. If you have a look at our spectrum analyzer, you can see we've got a nice, well-rounded shape to our bass, and that's because we've synthesized it ourselves in Sylenth. But sometimes, depending on where you've got the bass sound from or how you've synthesized it, there might be a bit of nasty resonances in there. So I'm just going to program that in now. So the reason I'm doing this is because it's a pretty standard situation. It happens quite a lot when you program your basses or you've got a bass sound and the fundamental or the first few harmonics, like up in the spectrum analyzer, are going to be a lot louder than the rest of the bass. And it can be the other way around, but generally it's going to be the fundamental or the bottom end is going to be much, much louder, and that's going to cause a woolly or sort of boomy texture where there's just too much sub, and you need to get rid of some of that to gain a bit of clarity. So any of you that have used an EQ device before will know that we can rectify this problem pretty easily by setting the frequency to the same frequency as the resonance, and then we can just cut it out and adjust the Q to get rid of it. But what we're actually trying to do here instead is sort out the tonal balance, and this is a much faster and more broad way of just getting our sound into a ballpark area of where we want it to be. And we can really cut out a lot of that subby, boomy energy really quickly, so we can use shelving filters to do this. So what we'll do now is we're just going to pull down the gain on this low shelf, and we can adjust the Q to make it more prominent at the cutoff point, or we can make it nice and smooth. So I'd say go for a sort of smoother setting, because if we've got a bass sound that jumps around and we're using a resonance setting, then we're going to have certain notes that stick out more than others. And then we can also use the high shelf, and we can make our mid-range a little bit more prominent and make the bass just a bit more present and accentuate those harmonics. And this is where it gets interesting, because we get rid of these two. So now we've got this kind of shape, right? And if we push this right the way up, we'll go to 9, -9. And we'll take this one to +9. Right, and this is where it gets really interesting, because what we can do here is we can either map these to a macro. Oh wait, just let me group this. Okay, so we can map these to a macro, or to make it even easier for ourselves, we can map the scale function. So we'll just map this to macro 1, and then if we click the map button, and we can open up our browser, and we can set the minimum and maximum for this macro knob. So we'll set it to -100 and +100. And now we've got a very simple tonal balance control. So we can change this from a dark to a bright tone nice and easily. So just so you can hear this. So this isn't obviously going to be a fix-all, and you're still going to have to do some surgical changes, but it's a nice way of just shifting the tonal balance so it makes a little bit more sense. Okay guys, so to better understand the relationship between the kick and the bass, what I've done is I've just set up this little project. So we've got a bass, and we've got a kick. And what I'm using is Voxengo's Gliss EQ. And I've put one on each channel. And what I've done is I've color coded these, so I'll just make sure that's correct. Okay, so now we've got our kick and our bass. And what I've also done is I've gone and renamed these and color coded them in Voxengo as well. So what we can do, firstly I'm going to explain the areas. So what I do, if I just turn this on, and this is what's really good about the Gliss EQ, is we can see the octaves here for the bass range, or we can see something basic like rough fundamental frequencies and areas for these fundamental frequencies. And then we've also got a few other things like octaves as well. And what I've done is you can actually make your own. So I've just loaded up my own custom template, and I'm going to load the same one up in here as well. And this is my own template that I've made. And this is my own template that I've made for when I'm working on things like trying to unmask the kick and the bass and get them to sit together nicely. So what we've got then is we've got our power range. This is from about 30 to 60 hertz, and it's sort of plus or minus sort of 10, 15, 20 hertz, depending on the track in question and what sort of parts and samples you're using. But generally speaking, this power range is going to be a lot of the actual power of the track. Is going to be the sub. And this can get quite boomy, and the decay can drag on a bit, so that's something you might want to keep control of. And the next range we've got is the punch range. So if we just play it, what I'll do is I'll turn on a bandpass filter. So this is our sub range of our kick. And the sub range isn't really much good unless it's got some punch on top of it. So this is our punch range. So you can see that's where it hits you in the chest, and that's what's going to also really drive the track, and it's super imperative to have that to help it cut through the mix, because it's not really going to do much on its own with just the power range. It's just a sub really. And then we got into the smack range, and you can hear this is still sort of punch, so the lines are quite vague and blurred. We've got smack / presence, and then this is where we go onto the toppy parts of our kicks. Around the 300 hertz is where you'd usually make a bit of a cut to reduce boxiness or muddiness or boom. You could also reduce boom down in the power. And then we got up here, and we've got presence right the way up here, and this can always help cut through the mix around 1K, 3K. So you might be thinking, why am I showing you so much about the kick in terms of the bass? But obviously we need to get these to sit well together. And the trick to doing that is to make sure that they avoid the same EQ zones, or at least in the power and the punch ranges. So we need to make sure that if the kick is going to occupy one range, then the bass can also predominantly occupy the same range. And just to show you this, if I press play now, what you're going to see is we've got our kick hitting at 49 hertz. And if we also had our bass hitting at the exact same range, that's a lot of very tightly packed frequencies hitting in the exact same EQ band. If we actually have a closer look at the bass range or our sub range here, then what we've actually got is we've got our entire bass range spanning just 30 hertz. So that is a lot of different note pitches in such a small space. So to try and get our bass and our kick and potentially maybe some fundamental frequencies of some other instruments in there, you have to be really careful about what and how you prioritize this range, and also the same with the punch range. And if you don't EQ carefully and make hard decisions about what gets into this range, then we're going to get a lot of mud, we're going to get a lot of boominess, and we're also going to get a lot of overs and clipping. So to avoid that, we need to use some very harsh EQ and keep them separate from each other, and that will give us our clarity. So what we're going to do now is we're going to move back to our original project, and we're going to look at cleaning it up with regards to the kick and the bass. So this dominates in quite a large range because obviously the octave jumps. And our kick is pretty specific. We've got a D sharp by the looks of it. And then it's probably got another bit of a pressure point there. And just so we can check this, what we can do is we can go to 3 and we'll go to turn on our Audition, crank this gain up. And I'll say about there, we've got a little bit of a pressure point, and it should be at 80 hertz, which is double our fundamental, which is 41, well, 82 hertz. But we've also got a little bit of a bump going on up higher as well, which isn't uncommon. So what we can actually do is just do a gentle boost there. So all we're going to do is a few little gentle boosts and just push the signal up, so we're highlighting these frequencies in the kick. And then what we're going to do is we're going to cut these frequencies in the bass. So we're doing opposites on the two tracks to make it stand out more, so the kick's going to punch through the bass. So looking at our bass, we've got quite a large frequency content from 40 hertz to about 375. So somewhere here we're going to be wanting to make notches or using a shelving EQ to cut some of that out so our kick can come through. And obviously if we felt our bass was more important in the track, then we might want to do this the other way around. It's all about prioritizing what's more important within the track. And most of the time that's going to be your kick. So I'm just going to scoop that out with a low shelf and A/B this to see how it sounds. How it sounds without. And even just with this. Or we could get more precise, and what we could actually do is cut those exact frequencies that we mentioned. So we can say 40, 80, and let's just double check. About 260. So these are areas that we can cut. And if we just notch these out with a sharp Q, then that's going to really help the kick come through. So immediately there we can hear that sounds a lot better, but we are actually butchering our bass track quite badly here. So what we can do is think about this in terms of time and try and sort the problem out dynamically. So if we look at our MIDI patch here, we can see we've got our first note, we've got a second note with our kick, another kick, and another kick. So what we can do is actually lower the velocity on each of the notes that hits on top of the kick, and that's going to stop it clipping at the same time as it hits the kick, but we are going to have a slightly quieter bass on this note. So what we can do is select them all like this, bring them all down to 0 velocity, and then when we bring them up, they're all going to be the exact same velocity. So we're doing it dynamically, and there's a few other ways we could do it dynamically as well. We could go to plugins and use something like FabFilter for AMD. Now this is actually compression, but it's very similar in how it works. So we can just do the exact same thing here, and we can sidechain it to our kick. So how we do that is we just press play, make a band. We want that band at 40. We want to compress, and we want to sidechain it. And what we're going to do is we're going to duplicate this kick, go into the input and output, and we're going to send the audio to bass 5. So now, so it's getting the kick from this kick now. And if we listen to this kick, this is still here fine. That's just still doing its thing. This one won't be heard. It's just to send to this. It's just called sidechaining, okay? And if we audition this, so this is now our bass. This is what our bass is listening to, and it's going to react according to this kick. So in band mode, it's going to use the same band from the kick. So in this case, it's using the sub. We don't want that because it's too flabby. So we'll put it in free mode for this one. And then what we can do is set the threshold, pull the range right down. We can pull this right down and set this to, there we go, set that to 42 hertz. And we can also use shift, and we can drag this up just to tighten up this high slip because we want it to notch out quite tight. And then we can reduce the attack, leave that as it is, make it hard, pull the look ahead forward, increase the ratio, and now it's full on ducking on that. And then we can also set another one up. About 260, and the same again. $240, that would do. External. And band doesn't sound too bad here, but we can still get a bit better in free. And once again, we can tighten these up. And we can either drag up like that. Ooh, sorry. Or we can just type it in. We unaudition that. And this will probably be a bit obvious, so what we need to do is readjust the threshold, but this should be going to the master. Oh, no. Bass 5. Solo the wrong one. We'll set something a bit more sensible. And that is how we can use EQ notches or dynamic EQ and compression to move the kick and the bass out of each other's way and keep the low end of our mix nice and clear. So next we have surgical EQ and peak filters. So I'm just going to load up an EQ8, and what we're trying to do here is in times when tonal balance doesn't quite work or we need to get really surgical, and we're going to go in with a peak filter, and we're either going to make small notches or we might have to make light boosts to get where we need to be. So all we're going to do is set ourselves a peak filter. So we'll just grab one of these shells. We use number 6 here. And we can use Audition if we want. And there's also Adaptive Q. I'm just going to turn the Q right up and put up the gain. And you want to put up the gain quite far, but you want to be careful with the Q, because if you set the Q too tight, then absolutely everything's going to sound resonant. And all we're going to do is sweep through the frequencies and listen for things that stand out. And if it really jumps out in gain, or it isn't a nice frequency to your ears, then you're going to know about it straight away, and then you can think about cutting it and changing the Q to suit the notch that you're trying to make. And if you look on the actual spectrum analyzer behind, you can usually see when there's a bad resonance as well, because it will stick out awkwardly. And something to be careful of is just because it sticks out awkwardly doesn't necessarily mean it's definitely going to be a resonance. Sometimes it is a nice frequency that sticks out. So when we find something that we don't like, that might be because it's too boomy or boxy or woolly, then we can just bring down the gain, and then we just adjust the Q so we're not butchering our signal. When we're cutting, we only want to cut exactly enough to get rid of the resonance. We don't want to be cutting anything more than that. So to that end, try to keep your gain cuts quite small and efficient, so only cut as much as you need to, and set the Q as high as you can get away with putting it without leaving any resonance in the signal. So remember to just keep sweeping through and use as many bands as you need to, but don't feel that because you've got 8 bands you've got to use every single one of them. And once you've set all the bands, what you can then do is make an A/B comparison by using the bypass button and check it actually does make a beneficial difference. Make sure you're not doing this in solo. You must be making these cuts in context. So keep referencing back to whatever other track you want to be unmasking, and make sure that you are making a difference using the information from that track. So you might have to keep going to the solo and mute buttons to check that it is actually helping your drum track or your vocal track or your kick track. So this skill takes a little bit of time to get used to, but what I'm basically doing is muting and unmuting the bass whilst listening to the beat. And it's important that you pay attention to the beat and not the bass when you're doing this technique. And what I'm listening for is when I bring this bass instrument back in, does the kick or does the beat change in any form? Am I losing any sort of definition or clarity from the kick drum in particular, or the bottom of the snare? Is there anything that changes when the bass comes in? And that is a good way of finding out what sort of adjustments I need to make to the bass so it doesn't affect the kick or the beat when they're played together. Another point to think about is in terms of headroom. So if we play our bass instrument and we take a look at the spectrum analyzer, we can see our individual frequencies sticking out here. And if we want to get extra loudness, then we need to think about EQing these frequencies so they're not popping out. So what we're trying to do is flatten off and get a nice flat sound so it's nice and even. And what that means is that when we turn up the gain of this track, or we add things like saturation, it's going to bring up all of these different frequencies equally. So that's why we use things such as compression to get as much sound as we possibly can, or as much level as we possibly can. And obviously we are going to lose a lot of dynamics doing that, but it is a certain way of getting extra loudness. So that's why we tend to use things like EQ before compression to remove everything that we don't want within the signal. And then we compress, and then we use EQ boosts to level out or get the tonal balance of our sound right. And that way, at each stage, we're going to maximize the loudness before we go into the master bus and start hitting things like bus compression, and then limiting as well. So if we go a step further with EQ, we'll learn that we've got different EQ plugins for different tasks. So typically, if we're going to make EQ cuts, we're going to use a linear phase EQ, because what that's going to do is it's going to keep the phase the same, so we're not going to have any changes in colour or tone due to the phase relationship when we're making these cuts. So here we've got the Waves linear phase EQ. which is a nice simple one for making our little surgical notches. And we've also got the FabFilter Pro Q2, and we can also change this to linear phase mode as well. So I'd suggest when you're working on your track, just use minimum phase first, and then you can set it to linear phase when you bounce out for your notches, because otherwise you're going to have a massive latency on your track. So if you're trying to make cuts, linear phase is the way to go, and this will add a latency. So just to show you, this is me pressing start now. Ready? As opposed to low. So as you've heard, if we use linear phase in maximum mode, then we're going to have quite a hefty delay on our signal. So I suggest when you're working on your track, work in a lower setting or a minimum phase setting, and then you can change it before you bounce your track out, just so you're not having a problem with stopping and starting audio and large latencies. So that's linear phase for cuts and notches. And if we're going to make boosts, then we should actually be using minimum phase, because it's a little bit misleading with the title, but minimum phase is actually going to make small phase changes at the point at which we are boosting. And with vintage analog type stuff, this actually sounds really nice. So there's absolutely loads of different vintage analog emulations out there of EQs, but within Waves we've got the PuigTech EQ-P1A, which is a high and low shelf, and we've got the MEQ5, which is a mid-band EQ, and we've also got something similar from Native Instruments as well. So these particular EQs emulate the Pultec EQ, which is a very highly regarded EQ unit, and that's because of, like I said, it's phase changes that it puts on the signal around the point that you're boosting, and that's going to add a nice coloration and saturation to the sound. So a few points to go on with EQ is you can't boost what isn't already there. So sometimes it's more useful to go for a distortion or saturation if you're trying to boost and put some more stuff into the signal, and then you can go into EQ and shape it a little bit better. There's no point trying to EQ and boost a sine wave because it's only got a fundamental frequency, so there's not going to be much there for you to add to the signal. And also, when you are going to be using things like saturation, distortion and EQ, try not to go too crazy with the boosts, because really massive boosts will sound quite unnatural depending on the curve you use, and you don't want to be making extra resonances in your track than there already are that you need to get rid of, because you'll find that other elements won't sit on top whatsoever. Things like your drums and your vocals aren't going to sit on a lumpy bass because you've been EQing the heck out of it and adding in loads of frequencies that don't need to be there. So also, if you look at our little VU where the needle is, our little gain reduction meter, you can see we've got a little red dot. I'll just turn that off, and that means that we've got an over. It means we're clipping our specific device. So with old compressors and EQ devices, the level at which you're putting into the device is going to make a difference. If you put too much in, it is going to have saturative type effects on it. And as well as that, be aware of things like the main switch. So we can turn on hum at 50 and 60 Hertz in a lot of old compressors and EQs. So I'd recommend leaving that off unless you want it in for a specific reason. So now we've covered everything to do with EQ. What we're going to do now is take a look at some other processes when it comes to mixing bass.